Again, this whole unit, we're just building and building each new lesson we have. And today's new lesson is going to be the same stuff as yesterday. We're going to have to be combining some like terms, potentially. We're going to have to use our inverse operations from Monday. But now we're going to have to deal with variables being on both sides of the equal sign. If you think back to yesterday's worksheet, we only saw whole numbers on the right-hand side of our equations, right? Equals 4, or equals 10, equals 6. We saw that a lot on the right-hand side, but we didn't see any variables on both sides. So that's what we're going to be tackling today. The most important thing to keep in mind when we're going through this work is that if we want to move a term to the other side of the equal sign, you have to use inverse operations. You cannot just take it, write it on the right-hand side, and be good. Okay? Because when you move it across the equal sign, the sign of that term changes. If it's a negative on the left, it'll be positive on the right. If it's positive on the right, it's going to be negative on the left, right? That's how we're able to move it, is by using inverse operations. So this is just, we've already talked about that. That's really nothing new. Let's just take a look at an example. And let's have the example be, how do I want to do this?
You should just take it straight off your homework. I'm sorry.
No, not this time around. Okay, let's go 3x plus 4 equals 5x minus 2. There we go.
How long?
I don't know. Hard to tell. So, 3x plus 4 equals 5x minus 2. This is something new that we have not seen yet before. We've got an x on the left, and we've got an x on the right. So what we want to do here, and we could just write this off to the side, we could say that our goal here is to get all of our variable terms to one side and all constant terms to the other side. Let's go ahead and start by drawing a line through our equal sign. It's especially helpful with this type of problem because we have variables on both sides. We don't want to accidentally combine like terms together when we really need to do inverse operations. So the two terms in orange, those are our variable terms. And the two terms in lavender here, in purple, are our constant terms. Are you able to see those colors okay?
Yeah.
Yeah. That's good.
Is that one better?
Yep.
Okay, all right, we'll go with that. That's fine. Okay. So we're going to get all our variable terms to one side. We're going to get all our constant terms over to the other side. Typically what we want to do is move our variable terms over to the left, right? Because we're used to seeing x equals blank. We're not really used to seeing blank equals x and having our variable on the right-hand side. So if you want to keep it kind of consistent, you can just always move your variable terms to the left and always move your constant terms to the right. It doesn't matter which side you move them to. One side is typically easier than the other, though, and we're going to figure out how to determine that at the end of these notes here. So let's go ahead and move our variable term, 5x, over to the other side. If we have positive 5x on the right-hand side and we want to move it, we're going to have to do an inverse operation, right? What would the inverse of positive 5x be? Minus 5x, right? So we're going to subtract 5x from both sides. And we want to make sure that our 5x is written in line underneath 3x, okay? We're subtracting 5x from 3x, not from 4, from 3x. So this is why I stressed the other day when we started this, lining everything up is very, very important. If you're already in the habit of lining your equations up, great. You're not going to run into an issue here with this work. But if you haven't started, please definitely start with this. Line up every single term almost as if there's columns here that won't let you write anything in the middle. Okay? So, what does 5x minus 5x equal to? 0, right? They cancel each other out, just like 5 minus 5 would cancel each other out. And we're just left with minus 2 on the right. We also have plus 4 still here on the left. But what's our new variable term going to be?
2.
Very close.
Negative 2x.
Negative 2x. That's our whole term right there. The coefficient would be negative 2, but the term itself is negative 2x. It's the whole thing. So it's the exact same as if we were subtracting a whole number or an integer from one side to the other, except we have an x attached. All right? Give me a thumbs up if you see how we got negative 2x here. Ooh.
Oh.
Only a couple of people?
What was the question?
The question was, give me a thumbs up if you see how we got negative 2x here. Okay, good. Yes, Miguel. Oh, did you just have your thumbs up? Okay, perfect. So, we've got all our variable terms over onto the left-hand side. See how all of our orange terms, there's only orange on the left? That's good. We're halfway done with what we need to do. But now we have to get all of our purple constant terms over to the other side of our equation. We're going to do that once again by using inverse operations on the plus 4. How come we're not going to do inverse operations on the minus 2? Why did I decide to choose the plus 4? It's in the equation. Good. What's that, Jordan?
There's no x.
There's no x. That's right. But I'm saying if I'm moving 4 over here, right, we're going to subtract 4. How come I'm not adding 2 to the other side instead? Jordan?
Because it's not a like term.
4 and 2 are like terms.
I like 2x.
Okay. We'll come back to that. It'll make more sense later. Don't worry. So we got positive 4 here. We're going to move it over here because we just moved our variable terms over to the left, right? We moved that 5x over to the left. So now we're going to compensate for that by moving this 4 over to the right. 4 minus 4 cancels out, leaving us with minus 2x equals what? What would negative 2 minus 4 give us? Negative 6, right? Yes.
I think I know the answer to that question and why you add 2.
Okay, why? Well, why didn't we add 2 to the other side?
Because if you did, wouldn't that mean you have to cancel out the negative 2 and there wouldn't be anything to solve?
Exactly. Thank you. There we go. If we did plus 2 to both sides, we wouldn't have anything left on the right-hand side. It would just be a 0. And that's not really aligned with our goal now, is it? Our goal is to have the variables on one side and the numbers on the other side. That's our whole idea of doing this. Have we achieved that right here?
Yes.
Yes, we have. Our variable term is over here. We're not done yet, but our variable term is on the left and our constant term is on the right. Right? Think about it like this. On this left side of the equation, 3x plus 4, let's say the orange terms are 8th graders and the lavender terms are 7th graders. All right? So this left side of the equation, this is 7th grade lunch. Okay? We've got a 7th grader here, but hey, wait a minute, there's an 8th grader there. You're not supposed to be at 7th grade lunch.
I thought you said the orange was 8th grade.
Did I?
Yeah.
Oh, well, other way around. So there's a 7th grader here at 7th grade lunch like he should be. But wait a minute, this 8th grader is at the lunch. He's not supposed to be there. We got to move him back over to 8th grade lunch, and we got to move the 7th grader back over to 7th grade lunch. Does that make a little sense?
Yes.
Maybe?
Kind of confused me.
Maybe it confused you more. I apologize if that's the case. Yeah, go ahead. Basically, you have to sort them. You have to sort your variable terms onto one side and your constant terms on the other side. But you have to do the inverse in order to achieve that. So, now we have negative 2x equals negative 6. We'll just break into our multi-step solving. What do we do from here?
Divide by -2.
We're going to divide both sides by negative 2 because we're multiplying x by negative 2. Inverse of multiplying is going to be to divide, right? Negative 2 over negative 2 cancels to 1. And what is x going to be equal to? Positive 3. Remember, a negative over a negative cancels out and becomes positive. And 6 divided by 2 is going to give us 3. And notice how as we went through that equation, those blank spaces in our equation got larger and larger, right? That shows me right away I'm keeping all my terms in line with each other when I have those big empty spaces, right? Because what we don't want to do is do minus 5x. Let's say we did minus 5x and then minus 5x, right? If we place the minus 5x underneath the 4, we're going to mess ourselves up and get something like, I don't know, like negative 1 or something. And then we have a completely different equation there. So we'll take a look at a bad example in a second, but let's go over another good one. Let's do... This one's going to be kind of a doozy. Let's go 7a minus a plus 4 equals 2a minus 8. Ooh, there's a lot going on there.
That's what it is. 7a minus a plus 4.
So by the end of this equation, after we've done everything we need to do, we should have a statement that reads a equals a number, right? Our goal is to have the variable isolated on one side and our constant terms all banded together on the other side. So let's go ahead and split it right down the equal sign first. Again, do that before you even start worrying about the numbers. You want to make sure you know which side is which, so we're not moving things to the wrong side. How many total terms do we have in this equation? Go ahead and show me on your fingers. How many total terms are in this equation? 10. Oh, okay, good. I see all 5s. We got 5 terms. What are our variable terms? Who can name what our 3 variable terms are going to be? Jordan?
7a and 2a.
Perfect. Are those the only 2 variable terms in this whole equation?
And a 4 and -8.
Well, 4 doesn't have an A on it, but negative A is an A, right? What are our constant terms now? 4 and negative 8, right? So this problem is a little bit different. Now we have 5 terms to deal with instead of 4. Yes? Go ahead. Luckily for us, we learned 7.1b yesterday, and we talked about how to combine like terms on the same side of an equation first. So we're going to have to do that here. Off to the side, let's write a note. So before we start our inverse operations, we're going to have to combine like terms first. Which 2 like terms are we going to combine? Are we going to combine 7a and 2a? No, why can't we combine 7a and 2a?
Because they're not on the same side.
Thank you, they're not on the same side. So there's 2 different instances here. We have like terms on the same side of the equal sign, like terms on opposite sides of the equal sign. When they're on the same side, like 7a and negative a, we're just going to combine them together. But if they're on opposite sides, that's when we have to do the inverse operation. Okay? So when we move across this line here, that's when we have to do an inverse operation. But right here, we just solve it exactly as we see it. 7a minus, how many a's are here again?
1.
Just 1, right? So if we loop up 7 minus 1, bring it out in front. 7 minus 1, a plus 4. Remember, do not group that 4 up with your variable terms. So all we did in that first step was combine like terms. We took the 7 minus 1 away from our a's on the left. And we get a new coefficient for a. What is our new coefficient for a going to be here? 6, right? It's just 7 minus 1. That gives us 6a plus 4 equals 2a minus 8.
We're gonna go ask what they were talking about. Take a look.
Now we have an equation that we can start using inverse operations on to get everything that needs to be on the same side together on the same side. All right, when you see variable constant equals variable constant, you know you can start moving stuff over. But if we have too much going on, we've got to combine what we can first, okay? All right. First things first. What are we going to move and where are we going to move it? There's 4 different options we could take here. But actually, let's start with just the variable terms. Do we want to move 6a over to the right, or do we want to move 2a over to the left? What do you guys think?
2a to the left.
2a over to the left. Why do you say 2a over to the left?
So it's like a like term.
Because it's a like term? Yeah, but why did you choose to move 2a as opposed to moving 6a? Make the equation easier, Noah?
To make negative 8 by itself.
To get negative 8 by itself? Perfect. That's a great answer. What do you mean by make the equation easier, Azalea? Why would that make the equation easier? It would make the equation. Yeah, go ahead.
Because when you when you put the 2 over to the 6a, it would just like become a regular equation with like the variable plus 4 and then equals negative 8 by itself.
Okay, yes. So you're saying we're going to bring the variable term over to the left because usually we see the variable term on the left, right? Absolutely. Great answer. Great answer. Let's do that. Let's move 2a over to the left. The inverse of positive 2a, even though we don't see a plus sign there, it's positive. So we have to do the inverse, which would be to subtract. What would 2a minus 2a give us? 0. They cancel out. Those cancel to 0. And what does 6a minus 2a give us on the left? 4a, right? 6 minus 2. Giving us 4. I'm going to move this up a little bit so you can see. Are all of our variable terms on one side now?
Yes.
Variable terms.
Yes.
Yeah, they're all on one side.
If I just keep it back.
But now we have to move this constant term over to the right as well.
No, it's
How do we do that? If it's plus 4, what do we have to do to both sides?
Minus 4.
Yeah, we're going to minus 4. Thank you, Azalea. And Noah, I appreciate that. We're going to subtract 4 from both sides. Yeah. 4 minus 4 cancels out, giving us 0. Negative 8 minus 4 gives us what?
Negative 4.
Negative 12, right?
You say negative.
Now, final step is to do what to both sides? Divide both sides by 4. How did I get what now? Okay. I would love to answer any questions you have because this is kind of a long process. 4 over 4 cancels to 1. A is equal to negative 3. A lot of steps. A lot of steps, right? That's why it's important to keep all of our steps in line. Because if you start shifting things around, things aren't lining up correctly, and you get to a point of confusion, you're going to go backwards and not even know where you messed up. So if you keep everything in line like this, you'll definitely be better off, I promise you. I'm going to add in here just what we did. So there's our steps right there. And then the first thing we did was combine our like terms. Okay, questions on example B at all? Did I lose anybody within that process?
No, sir.
Okay, if I did, we'll figure it out during the worksheet, don't worry. Okay. Yeah. I'm going to go ahead and say, just bring your variable terms over to the left. We're not going to worry about what makes it easier to solve or anything like that, because I feel like that's just going to confuse you guys more. So let's just stick with that. Move your variable terms over to the left. Move your constant terms over to the right. The reason it has to do with dividing by a negative number, but I feel like we're pretty confident on our dividing by a negative number skills, so we're not going to worry about that. Okay, let's get this worksheet going. shall we? Once I get this passed out, we're going to do number 1 together, and then you'll be on your own just so we can get started on the same page here. Did you guys learn the distributive property last year at all?
Yeah.
Oh, nice. Tomorrow will be super easy then. Okay, let's talk about number 1 real quick. Am I still recording? Oh, I am.